through and do is going to be once we get that first step done. Go ahead. So what's it going to look like when we distribute that out, please?
Negative 5x minus 15y plus 8y.
Okay? And from there, hands up please, and tell me the last thing that needs to get done. Go ahead. So what are we combining? And what do you get when you put those together? Okay? And what else can we put together? Okay? And what do you get when you put those together? Final answer. Questions on that one? Now, and that's how quick we really should be able to get those done. You all had for homework, which one on page 5? Page 5. 4. Page 5. What did we have? 1 through 16. So which one did we have questions on? Hands up, please, and tell me any of the ones you want to go through and see. Yeah. Okay, so if we're looking at 15 and 16 are essentially the same. Let's go over and do 15 to start. If I have 15, I start off with x squared y squared plus 12xy and then plus 18. Now, when we're breaking this down, and this is something that's even going to come up today, this right now to you may look slightly confusing. What could I guess we'll say this. There's something that we're going to talk about a lot of times. When you see a situation that's really, really complicated, break it down into something that's similar and something that you know how to deal with. So in this case, when I look at this, this looks kind of difficult. Can you factor that? Hands up, please, if you can factor that. Hands up, please, if you can factor what's in the red. Were you able to factor what's in the red? What did you get? What was that factor to? What's in the red here, not the green?
20 of x plus
Do we have numbers that multiply to 18 and give us 12? Go ahead. 9 and 3? What's 9 times 3? We've got choices of, what are the factors of 18? 9 and 2. Do 9 and 2 give us 12? No. What else do we have? We do 18 and 1. Is that going to give us 12? 6 and 3? No. Is there any more factors of 18? So before we go too far, what do we want to say about the red? What do you say? Yeah, it's prime. And let's make sure we're using, because a lot of times you say, well, it doesn't factor. What is it called when it doesn't factor? It means it's prime. So if this right here is prime, then guess what? How does the red differ from the green? Just that extra y that's on there. So what conjecture can we make about what's in green? It's prime also. Now, the other one that you looked at was 16. To start off with for 16, that's what we're given. We've got p squared q squared minus 5pq. Q, and then minus 18. Now, instead of factoring what's in blue there, think about a similar equation that's more manageable or similar to what you've done before. And if I did that, it kind of looks awkward. I've got two squared terms and a linear term and a constant. What about if I had this? So as I start to do that, let's look at the factors of 18 again. What are the factors of 18? Let's try 9 and 2. Can that give me a negative 5? No. What was the other one? 6 and 3. Is that going to give us a negative 5? What about, what was the other one that we did? 18 and 1. 18 and 1, is that going to work? So guess what? I was trying to make it a little bit easy for you because sometimes, again, you get it drilled into your head that everything that you're ever going to encounter factors. It doesn't. Not by a long shot. Okay? It happens in life. That's fine. One thing, remind me before we leave today, I'll show you, there's a website. Raise your hand if you've ever seen or used the website Wolfram Alpha. Some of you have? Okay. It is so wonderful. Because instead of, like, if you're getting frustrated at home, these will not factor, but there's even an app, I think they even make an app for that website, and I think it's like $1 or something like that. But you can go through and type in factor that, and it will tell you what it factors down to or that it doesn't factor. And you may see if it tries to factor, but it doesn't factor, and make it really awkward and weird looking, and you go, oh, that's probably not what he's looking for. That doesn't look like the math that we've done before, so you say, oh, maybe this is fine. Do this for me now. Go over, please, to page 6 and have out on your desk your factoring checklist because we need to make sure today's the day we're actually going to be going and banging out way more examples than before, but you've got to be able to recognize what the different types are. Looking on there. Did your schedule switch? Is that why? Did you have a schedule switch? Remind me. I have to manually add it. Now, are you on this? Yeah. I don't even have you on there. That's probably why. We'll get it fixed. I know. First thing that we need to look for is a GCF. First thing that you have to look for is a GCF. Take a look at 1A. Is there a GCF there, yes or no? No. Second thing is this a difference of perfect squares? In a difference of perfect squares, you've got a binomial, two terms. Left side is a perfect square and right side is a perfect square. And what that means is something times itself gives you what's on the left, something times itself gives you what's on the right. Is that the case in 1A? You have conflicting answers. Who's confident in their answer? Okay, what times itself gives you t squared? What times itself gives you 36? Now, if you need it in the beginning, lightly write the square root of each half up top. That helps remind you what needs to be there. This is going to break down into two binomials. The square root of the left plus or minus the square root of the right. So you're going to have the quantity t plus 6 times the quantity t minus 6. Questions on that? Hopefully that's easy. Take a look at B. And this one's going to be a little bit awkward. I look at B. Some of you are going to want to say right away that this is what factor type. Take a look at what's there. Some of you are going to, there's one of two choices you should be able to pick out immediately. And half of them are correct. Hands up, please, if you can tell me what type of factorization you want to do first on it. So we can get 6. We got 1 so far. We do 2, 3, 4, 5, 6. What other choice would people falsely be lured into picking? What are you going to say? It would be difference of perfect squares also, but which one do we need to handle first? The GCF. The GCF has to happen before the difference of squares. What is the GCF that you can take out from both sides? 4, and when you divide that out or undistribute it, you're left with the quantity a squared minus 16. But you're not done. You need to stay vigilant. Hands up, please, when you can tell me what your complete and final answer for this would be. We'll see if we can get 5 of us. We got 1, 2 right away. Thank you. 3, 4. We're getting there. Quantity. Yeah, that's perfect. Go through right now, please, and do out C on your own. Hands up, please, when you can tell me what you got for C. Got 1, 2, so we need 7. 3 of us, 4. Stuck at 4. 5. 7. 6. 3 should be real quick. What do you want to say, please? There you go. Square root of the left gives you 4m. Square root of the right gives you 7p. It's just the left plus or minus the right. Questions on that? You should be able to hopefully pick that one up pretty easy. This next one is going to be tough. What type of factor pattern would we have in D? Does anyone see it? It's a little bit awkward to see in the beginning. You can go back down to E and come back up to it in a minute. What factor pattern does that look like? When I'm looking at that, is there a GCF there? Something in common to the whole expression? No. Next thing is it a difference of perfect squares? Look at the left side. Will something times itself give me 81k squared? Yeah, it'll be what? 9k. Now on the right-hand side, this is the part that shows like an algebraic weakness if we don't see this. Is there something that times itself will give me the quantity a plus 2 squared? A plus 2, yeah. A plus 2 times itself gives you a plus 2 squared. Now, your factor pattern is the same as it always has been. It's the left plus and minus the right-hand side. So the first thing I'd start off with is the square root of the left, which is 9k, plus the square root of the right, which gets us looking like this. So you've got 9 plus a plus 2. Not difficult. But we are going to probably make a mistake with the other factor. What would the other factor for this look like? Give it a try. What do you think the other factor is going to look like? We got 2 people who can take a list on this. Hopefully not that big. Go ahead.
9k minus a plus 2.
He said something in there wrong. He was close. You were close. What? The quantity of what? Why does the second one need to be in parentheses, but not necessarily the first? Perfect. There's a negative to distribute out there. Can we go forward based on what's there? And the answer is yes. What simplification can we do on this as it currently stands? What's it? Nope. Distribute my negative out, because that, if we distribute out, you're blowing it up, not factoring it down. So you're going sort of up the ladder when we're trying to go down. Remember, you're distributing out the negative to both pieces, and that's what you would be left with. Does the first factor change? No. The second one does change when we distribute out that negative to both halves of it. Is that difficult? Absolutely.
Can we get this on a test you want us to show the second step?
Yeah, I want you to take it and simplify it out, I guess, as far as you can. One thing, too, that's kind of interesting, when you all get to AP Calculus, I know for sure AP Calc, and in AP Stats, I believe it's the same thing. You actually don't need to simplify any of your answers. So as long as, let's say the answer to the question was like 4, you could list out as an answer 4. You could list out, 8 over 2. You could list out 16 over 4. You could list out whatever you want to, as long as it's equivalent to what you're getting. So they don't even make you simplify beyond high school. But on the REAPS, they'd expect you to take this out as far as you can. Questions on that one? I actually think E is going to be a little bit easier. Hands up, please. We'll see if we can get 8 when you can tell me what type of factoring E is going to be, just the type of factoring. We got 1, 2, 3 so far, 4. What do you want to say? Perfect. It's a difference of perfect squares. What is the square root of the left side going to be? Hands up, please, when you can answer that. And what about the square root of the right? What would that be? 9. So, who can tell me your first step in factoring down E? Hands up, you can adjust the first step for factoring down E. And you should be outraged and offended if that's the answer that you see left on the paper and I walk away. Why? Who looks at that and says, you're wrong? Who can tell me what we can do to go beyond this? Hands up, please. You should look at that, and every one of you should be going, there's more. I'm not done. You got one person, 2, 3, what do you want to say? Yeah, we can do the x squared minus 9. What would you give that as your final answer? Keep going. Keep going. And what else needs to be there? Because if you just wrote x plus 3, x minus 3 right now, that piece would be wrong. No? She correctly factored down this. This guy's got to come along for the ride Tuesday. If you can keep going, but don't forget what you need to drag along with you. Because that x squared plus 9 does not factor down. Why is x squared plus 9 not a difference of perfect squares? It's in the name. Why would x squared plus 9 not be a difference of perfect squares? Because it's adding. What does difference mean? What operation is that? Subtraction, yeah. So, those are our difference of perfect square ones. This one right now that we're going to go through and do is new for you. But it's actually, and it's one of those things where it's really just a rote application of a formula. We're going to work with sum and difference of cubes. Now, I think that's numbers 6 and 7, is that right? Yeah, 6 and 7 that are on there. The first thing you need to know are your perfect cube numbers. And a perfect cube number is a number that you get from multiplying any base times itself 3 times. Not twice, but 3 times. So 1 to the 3rd power is obviously going to give you 1. What's 2 to the 3rd going to be? Hands up when you can answer that. Don't go to the calculator. Think your way through. 8. What's 3 to the 3rd going to be? Hands up, please. 27. What's 4 to the 3rd going to be? 64. 5 to the 3rd. Hands up when you can give me 5 to the 3rd. What about 6 to the 3rd? It's going to be 216. And 7 to the 3rd is 343. We ask that you list those out just so you know them and you see them quickly. Now notice, there is only a difference of perfect squares, but there is a sum in difference of perfect cubes. So the first ones up that you need to know is how to factor a difference of perfect cubes. Here's your formula for difference of perfect cubes. If you have x cubed minus y cubed, the factor pattern is there's a binomial and a trinomial. It's going to go x minus y, and then x squared, xy, and y squared. The signs are going to be dependent on whether it's a sum or a difference. In this case, since it's a difference, the signs going across are going to be minus plus plus. Remember we said there's a binomial and a trinomial. When I talk about it being minus plus plus, that's what I'm referencing, the signs between them. In the beginning it is awkward. After about 2 of them, you should be 100% good. Take a look at question 3A. We've got to factor down that difference of perfect cubes. And I know it's the difference of perfect cubes because What is the cube root of m cubed going to be? Hands up if you can answer that. What times itself 3 times gives us m cubed? And what times itself 3 times is going to give me n? Hands up, it's going to give me 8. 2. So I write the cube root, not the square root, but the cube root up top. That is going to be your x and that's your y, or left and right whenever we're applying this formula out. Please keep in mind, how many factors will this break down into? How many factors does this have? 2. One's a binomial, one's a trinomial. So list out enough space for a binomial, and then list out enough space for a trinomial. What are your signs going to be going across? Hands up, please, if you can tell us what our signs are going to be going across. If there is a difference. What are the signs going to be going across in the back? So I'm going to make space for a binomial and a trinomial. And my signs going across, we just said, are minus and then plus plus. Now, the way that this gets done is it goes left minus right, or left right. So what's the binomial factor going to be? Take a guess as to what you think that binomial factor would become. Got 1, 2 of us. Perfect. So it's left, right. And then it is left squared. See how it says x squared? That's whatever's on the left. So your left squared, and then xy means left, right. And then the right is going to be y squared, or right squared. So take the left side and square it. What do I get when I take my left term and square it? M squared. And in the middle, I've got to take and multiply left times right. So what's the middle term going to be? 2n. And then, who can tell me what we would have here at the end and why? What do you think we'd have? 4, because you got to square the 2. That's it. Left squared, left, right squared. I want you right now on your own to try out 3b. Did I get rid of the in the last class? All right, so when we do this out, this is going to be a difference of cubes. First thing I'm going to do is take the cube root of the left and the cube root of the right, list out my binomials, etc. There is a binomial factor and a trinomial factor. Who can tell me what our binomial factor is going to be? We got 3, 4 of us, 5. Who wants to say 2? Looks good to me so far. left and right when you take the cube roots of them. What about on the right-hand side? What is that trinomial going to be? This is the one that's going to be really awkward because there's so many moving parts in it. We got 4 people. Give it a try. Close. You made one mistake in it, but you did make it twice, which is good. At least you were consistent. Remember, when you do it out, you got to square the number 2 because you gave them either 3. Is that right? Yes. This part, you've got to square both components of it. That's why it's 9x squared, because this left side was 3x. So 3x times the 3x gives me that. Questions on that one? Now, you're going to do the sum of perfect cubes. This one's going to be drastically different than you've done before, but not really. How is this different than that? What's the difference between our 2 formulas? Go ahead. Okay. Yeah, so our signs, if it's a plus going across, are going to be plus, minus, plus. Other than that, literally everything else is the same. The signs are different, and that's all. So if we were to do this one out, we'll do A together. I've got the sum of perfect cubes. The cube root of the left is going to be an R. The cube root of the right is going to be a 3. Who can tell me what our binomial for this factorization would be? We've got 2 people. We'll wait for 6. 3. What's the binomial on this going to look like? 4. We're getting there. 5. So far, we've done a great job. Our first binomial is R plus 3. What's the trinomial now going to look like as we go across? Go ahead. Plus. Remember, it goes plus, minus, plus?
Oh.
Okay. Questions on that? So go through right now, please, and do out 4 on your own. So if we go through and do this, hands up please, and you tell me what your binomial is going to look like. 3, 4. Yep. And when you do the trinomial then, the square root of the left, right, and then right squared, what's our trinomial going to look like? There you go. Questions on that? Now, we get to something like, well, this next question is going to be a sum or difference of cubes as well. What is the cube root of the left side in C going to be? Hands up when you can tell me that. To square that. Go ahead.
The
Cube root of it, sorry.
5t.
5t on that side. What times itself 3 times is going to give me 216 s to the 6th. What times itself 3 times would give me that out? We got 4 people. 5. No? Close. Yeah, this one's going to be 6s squared because s squared times s squared gives you s to the 6th. So if we do this, my binomial, will you tell me, what's the binomial going to look like? I think we can pick up the pace. I think we got it. Sounds like we got it. Go ahead. What's the binomial going to look like?
5t plus 6s squared.
You can tell me now what the trinomial is going to look like. This one's going to be a little bit awkward. Go ahead.
It would be 25 to 30. 25 to squared.
Left squared, that's where she got that. Keep going.
2
Close. What did you say it was? What's your middle term? Who takes issue with that? Negative 30. Okay. To the 4th. There you go. This example right here, just so you know, is another one of those ones that really is an upper level sort of enriched, push yourself type question. But it's also not that hard if you apply what we've done so far. Take a look at what we have to start. Is there a greatest common factor there, yes or no? No. Is this a difference of perfect squares? No, it's not even a difference, so how can it be a difference of perfect squares? Next thing we got to check for, is it a fast factoring? No. Yes and check? No. We do all of that. What type of factorization is that? You got numbers. Hands up, please, and you can tell me what type of factoring pattern that matches. Go ahead. Sum of cubes. So what's the cube root of the left? X plus 2. What's the cube root of the right? Now, who can tell me what they think our binomial is going to look like? What would our binomial look like? It's going to get awkward. Get over it. JB, go ahead. Yeah, and technically, do we actually need brackets there? No. We did it because initially it helps us with structure, and that's fine. The right side of this, I don't need you to make it big yet. Look at the right side of this. What's the trinomial going to look like set up? I don't need you to do more than just set up what the right side's going to look like. But what is that trinomial for this going to be? We got one person? Oh, come on. 2, 3. Give me an attempt here. Go ahead.
X plus the quantity of x plus first. And you square it, yeah.
Close. You said something wrong. It's x plus 2 squared. Keep going.
And then plus
minus
minus x
times t, right?
and then
Yeah. Now comes the awkward part, because I actually think, shockingly, that you can do more. Look at the initial binomial that we came up with. Can you clean that up at all? Sure. What can we do to clean up the binomial? I guess what would you list out as your answer for the binomial piece? No. You could do x plus 2 plus t. Do we need the parentheses there? Do those parentheses have to be there? No. So something like that. What math do you have to do over here that's going to be a bit of a bummer for you? You're looking at oh. What's in there that looks like, what math do you have to do inside those brackets that's going to be a lot of work? And you said it right, because x plus 2 squared means you're multiplying the binomial times itself. How do we multiply those two binomials together then? FOIL them out, or the rectangle of fun, whatever you choose. First terms, when we multiply them together, are going to give me x squared. My outside give me positive 2x, as do my inside. And then my last terms, they multiply to give me a 4. So really that turns into x squared. I think I combined my terms already. So as of right now, I guess this is, I've got x squared plus 4x plus 4 here. What can I do in this piece here? Distribute out the negative t, technically, if you want, you can put the t in front instead of back here. In any case, it would be minus tx, or xt, minus 2t, and then plus t squared. Now, one of the things that I love, and it always happens every year right about this time, there's this inevitable, and you go, oh my God, it's so much, it's so long. You know who you should get mad at instead of me? Everybody that you had before, these questions like that. If you can, is this beyond the scope of what you can do? No. And there's a big disconnect at times between what our actual abilities are and what we ask you all to do. I'll tell you this nicely. Well, did we go over what the kids gave as their responses last year after they left the Regents exam? Did I ask you how you all did on yours? Let's do this. Quick show of hands, and this is judgment-free area. Raise your hand if you did. Think about your fourth quarter grade, or sorry, not your fourth quarter, your 4-quarter average in class last year from Geo. Get a good approximation of what that was. Maybe in the mid-80s, or 90s, whatever it was. Think about what that number is. Now, think about the number that you got on your Regents exam. Hands up, please, if those two numbers are more than 10 apart. Hands up nice and high. We're not judging. Own it. At 10 or more apart. That's it. Anyone who is more than 10, that's it. More than 5. The other questions. I'll tell you this. One of the things that I go out of my way for is very seldom do I have a kid get lower than a 5-point discrepancy. On average, year over year, your 4-quarter averages from last year were 1.8% lower. So if you got a 90 during the class, you should be getting about an 88 or an 89 on the exam. That's what the expectation is. It correlates pretty good. But the difference is we're going to, let's say this, raise your hand if you felt, at least at some point during the Geo read, you were sitting there going, I have no idea what they're asking. So, I sent out, and I know that was going to be a problem because it happens every year. And it may be native to the course and it may not be. So literally last year, everywhere, okay. Last year before I left, after the kids left, I sent them a question, and you'll be getting these as well. Did you feel Oh, I think this is going to, oh, not there. Did you feel that the exam, like how did you feel? And this was immediately after. Now, the things, just so you know, that always scare me is when people say, I don't know what I didn't know. Because that means it's not that you didn't get questions right, it's that you don't even understand whole concepts. The things that we heard at the end that were promising, and the reason I was happy was that they were getting 88s for a class average, cycling too fast, a lot easier than I thought. The class was harder, which made the test easier. That's the point. I want you to screw up in here all the time. Like, I want you to make tons of mistakes. And I want you to go, oh, that's it. This is the part that should be hard. You get out of that exam, I thought it was easy. Let's see. I think I did well. There was somebody on there who literally knew the one question that they didn't know. Yeah, it's mutually, they literally knew the one topic that they didn't get right. But at least they knew, which means that everything else they really probably did a great job on. I felt well for parts 2, 3, and 4. It was harder than I thought. Multiple choice went well, but the response questions were difficult. I ran out of time. And the other thing is, like, they talked to their friends, and that was even reassuring. I want, and it's not to judge you, I want to push you in here. Because this is the stuff that really doesn't matter. That Regents exam, that's the one that even helps determine, like, college acceptance, because it's a standardized test across all of New York State. Your guidance counselors probably won't tell you, oh, the colleges don't look at it. Every single college looks at it. And if it's deciding between two applicants, one gets an 85 and one gets a 95, which one do you think they're picking if everything else is equal? The 95. What separates you out? Even when I have business majors, who are you going to hire? Which one sounds like a smarter person? Someone says, I have a degree in business, and then the second applicant says, yeah, I have a degree in business and economics. Which one sounds smarter? Business and econ. Why? Because the econ has math in it. And guess what people like to stay away from? Math. And guess what jobs make the most money? Math. You don't need to know it, frankly, if you go to real estate. If you wait tables. And by the way, waiting tables, you actually make a ton of money doing there. Make sure you understand all the jobs that involve a lot of math and logic skills you need to, we're going to get you ready for. The other thing, too, is actually, does anyone have lawyers in their family? Okay. In order to be a lawyer, you have to take an exam called the LSAT exam, and we actually save, I have a bunch of old ones that we do in here over breaks, because 40% of the LSAT exam are logic questions, which is just sequencing, which is a math thing. And at times we'll give you these things here to take as multiple choice, so we're giving to you as a group. It's about ordering stuff. Even if you want to go and be a lawyer, something where you didn't think that there would be much math, there's math. So you've got to make sure, you do well this year and you push yourself in here. Get used to thinking. I'm not going to ask you to combine like terms for the rest of the year. As far as homework, what I ask you to do is, we can go through, let's try this. Let's please have you do, let's have you try 16 through 21 all, and let's have you do 37 through 57 even, or sorry, odd. You can do them right in that paper, I really don't care. Okay. Do we have questions on that? Okay. Coming up in not next class, but the one after it, you're going to have your first quiz on factory stuff that we've done so far. If you got questions, feel free to come on in and ask them.